Okay, for people joining this live stream, we are looking at some incremental language development for Wolfram language and a bunch of features that we're hoping will make it into the upcoming version 12.3. So, first we had lexicographic order.
Yes, so this example shows the main idea that we look at the first elements before looking at the lengths.
Right. So, I mean, if you give it strings, will it do something?
Not this function. That would be alphabetic order.
Is that the right thing? I mean, most of our functions have, I mean, is it obvious that it shouldn't do something with strings?
It could do something with default settings, but if you go to alphabetic order, you will see that it has lots of settings. That,
oh, I know, I understand that, but I'm saying do it with the default setting.
Yeah.
If we were to check that the both inputs are strings, yeah, we could set it to alphabetic order.
By default.
Yes, because right now the default is order.
Right. Or what we could do is to automatically convert to characters of the string, which gives a list, and then we proceed with those characters.
That seems very sensible to me. But how do you sort? So the subordering inside lexicographic order is order. Is that correct?
By default, yes, with an optional third argument.
I see.
Exactly, because numerical order, for example, will be useful, things like that.
Right.
We could have even lists of strings, and then we would have lexicographic order with alphabetic order as element order.
Yes, I understand. That makes sense. But I mean, so then, okay, so a string would be treated here as if it was a list of characters.
Right.
That seems sensible to me.
At the top level, I can do that. In other words, if you have two strings, sure. But if you have lists of strings, I don't think we want to do that.
No, we don't.
Okay.
And it just goes to the order function that's in
yeah, fine. And they can specify alphabetic order if they want. Okay, we'll do.
Okay.
So something a bit problematic here is that these functions work on composite objects. So the important elements are the elements of the lists. So that's why in the documentation on the left, if you go up a bit, you'll see that I use these lists A's and B's to emphasize this importance of the actual elements.
Right.
It's difficult to explain. If we're going to compare A1 with B1, then the explanation gets very long.
Well, you can certainly say it in the details. You can say, you know, are considered in order in if you know, if the A sub I, if the B sub I are greater than the corresponding A sub I. I mean, I think you should have something in the notes that explains what this is.
Right. The second note tries to do that, but it's too short. Should be.
I think it needs to give a little bit of the math of it.
Right.
And it should say if it takes things other than lists, because the usage looks like it only takes lists.
Yeah, indeed.
And
yeah, we agreed on that.
If it's an association, is it just the values?
I think so. I followed suit with what other sort functions we're doing with association.
Good.
Basically called association sort after giving the order function, creating and passing the order function to it.
Well, so in other words, it sorts the values in the association and it pulls the keys along when those values are in reordered. Is that correct?
I assume so. I don't actually know much about our sorting code for associations.
We should check that. If it doesn't do that, then let's worry about it. But if it does that, I think it's fine.
Okay.
Well, it should just return the associations as they are. It's just telling you if they're ordered or not. I mean, it doesn't return them.
Not in the case of sort.
Yeah, but it should only be looking at the values. Oh, in the case of sort. I was thinking about the order one.
But okay. when it sorts the values, it drags their keys along with them.
Right.
So I think those are two different things. That would be lexicographic sort of an association, which is different from lexicographic order of two associations.
I agree.
Right. I was thinking about the latter.
Right.
Okay, so lexicographic order should just look at values. Is that what we're saying?
Yes.
But do the keys have to agree? I think the keys have to agree, right?
No, I don't think so.
Which is completely independent of the keys.
I would say that's more flexible.
And then you can do a key sort. So, I mean, I guess you could do a key sort with lexicographic order as the sorting function.
Right.
Okay, sounds about right to me.
One thing on the documentation that you might consider, Jose, is for lexicographic order is for things like and or, we do mention the short circuiting property. So that would hold here as well.
What does that mean?
That as soon as you have a definitive comparison, you stop.
Yes,
As soon as they're no longer equal.
Yeah, it's probably worth mentioning. Although it doesn't really have an evaluation consequence, which it does for and or, because and or are whole functions.
Sure. Yes. Yeah, that's true. Well, here it could go in details and options. Doesn't have to be in the use. The description.
I mean, okay. All right. Let's go to the trees, so to speak. Sander was commenting on our live stream that he liked the IJ Dutch example. Good. Well, glad we got it right. Okay. All right.
So here there are multiple functions, and I think the last time we discussed about trees, we had some open questions. So here we report on what we decided, mostly the second point, the tree map point. And then there are a couple of
Okay,
questions.
wait a minute. Should tree automatically canonicalize?
Mm-hmm.
Tree of data.
So we agreed that with one argument, it means children.
Yes.
So the question is whether for uniformity of results, we want to convert always to two arguments.
I don't know. I would say probably yes. Does Ian have an opinion?
I would like to canonicalize it.
Mm-hmm.
Okay, well, I think let's go with that for now. Okay. I mean, unless it turns out that we just have, it's just full of cruft when you do operations on it. Okay. I mean, you will rarely see this. Okay. Right. Tree map.
Right. So the difficult question here was whether to map on the subtrees or the payloads. And what we are proposing is that because tree map has a level spec specification, we consider some sort of notion of extended level spec in which you actually say, I want the data or the tree. And this can be used in various functions if they have a level spec.
Okay, but normally a list level spec is a span.
Yeah, so if this is 1 to 3 levels, then this would be the pair list 1 to 3, comma data. And you mean the data of all those levels.
Wait a minute. An ordinary level spec is either a single level or a span, right?
Or I mean, it's not a span. It's either a number or a list.
Okay, but that list actually probably we should also support span because it actually means a span, level 0 through 7 or something.
Right. Yes. It may be that it is supported, but
okay, fine.
I don't use it.
Okay. All right. But so that's the meaning of levels normally.
Yes.
Is levels A through B. And
right.
We certainly could do that for trees, have levels A through B, correct?
Correct. Yeah.
Okay. But what we're saying here is we are defining a way of map operating that says look only at the data in those specified levels, or look only at the subtrees at those specified levels.
Right.
Correct?
Yes. And by default, which one did we choose by default?
Data.
Data. Mm-hmm. Yeah, I think that's the most useful case in general.
Right. Okay. So here we got a tree, we got a function f, a tree, it's mapping over data. So, and if I say down to level, if I say that, it will map all the way down the tree. Is that correct? What does it do by default?
That's correct. It maps on the data from level 0 to infinity.
Okay, which is like map all.
Yes.
Okay, if I want it to map only on the leaf nodes, what do I do? Do I say -1 here?
Yes.
Okay, so I would argue in the world of stringiness that we might want this to work.
I like that.
And then if we did that, you know, or subtrees, that seems fairly civilized to be able to, those are the two cases, and the default is data, but I mean, that would be fine. We could just say data there. And these would be the all levels versions of this, okay? Leaves obviously isn't an all levels version because it's just the leaves.
Mhm.
Although, let me make a point that you could want leaves only down to level such and such. See what I'm saying? You could want leaves. I mean, this is not something that we have in ordinary map, right? In ordinary map, is there a way of saying, I want the terminal nodes? Yeah, this is a case that we want here. We want terminal nodes beyond level 7 or something. You see what I'm saying?
Yes, I think so. Well,
And
once we have this pair notation in which we have the standard level spec, comma something, we can express those things in the second argument.
yeah, I understand. So in particular, what that's saying is, I want to look at, okay, how does this work? I'm considering these bands within the tree. Oh, how does that work?
Well,
I mean,
so
you know,
leaves is corresponding to certain levels, and subtrees and data are referring to what portion of the thing at particular levels that you're mapping onto.
yes, that's correct. But what I'm saying is that leaves could also be treated differently. That is, you could say, I want the leaves, but only the ones that are below level 3, for example.
Mm-hmm.
All right, so now the question is, what do we do with the ordinary level specs here? And by the way, leaves, well, leaves, there's only one thing that could possibly mean. It's data and the leaves, right? There's no subtree there.
Could be a subtree.
Well, then does it have to be called leaf data?
So leaves means it's equivalent to -1, right?
Yes.
So then we could have list leaves, comma data, or leaves, comma tree.
Comma subtrees.
Subtrees, yeah.
Right, fair enough. And the most common case is just data.
Right.
Do you need 3 elements in the list?
What's the third?
Like from levels 3 to 5, just leaves.
So that would be list 3.5, comma leaf.
Got
Yeah,
it.
I think so.
Yep. Okay.
But if you wanted to specify leaves and data or leaves and subtree in addition to that,
You're toast. Do
Yeah.
2 tree maps. Because tree map, I don't even see how you could do that. Yeah, you'd have to take the tree. Now, normally with data, the return value from F is just restuffed into the data slot. The return value for subtrees the return value of f with subtrees is presumably supposed to be a tree because it's got to be re-glued into the tree.
It also gets stuffed into the data.
Really?
Yes.
So what if I want to do something where I rewrite the subtrees?
That's going to require something like tree replace.
So, but the analog in the case of ordinary map, it does replace the subtree in the expression, right?
Yes, but with ordinary expressions, we don't have the distinction of the subtree and the data.
No, I understand that. But I'm saying that it does do the replacement of subtree as opposed to just replacing at a certain level.
Yes.
So it's a little different from this. Okay, but so now the question is, I mean, my tendency would be to say that it's nicer to have something of the form levels, arrow data. I don't like this list data because it's saying, it's not like after you've done the levels, then you do the data. Rather, data is sort of a footnote or something to the level specification.
Mhm.
That's what I would prefer. Comments on this?
Well, being the last argument, I mean, if there are options, I do like the arrow. I'm just a bit concerned with options.
It'll be fine. I mean, that's what options pattern deals with. It'll be fine. We know what the options are, and they're certainly not lists of numbers.
Right. Okay.
All right, sound reasonable? Now, I could imagine that there are some other named things in addition to leave, subtrees, data. I mean, I don't know, but that's a good start at least.
Mhm.
And so levels, arrow, leaves would give us presumably just the leaves, less the leaf data. I mean, it's a little bit weird at those levels.
But leaves is equivalent to level -1.
Yeah, I know. So maybe we don't have that combined. Maybe that's just a first argument there.
I think so.
Okay. I mean, we can worry about the thing where you want the rim of the thing only down to level such and such later. Okay.
Mhm.
Tree data structure.
Yes. So the main question here is how to convert from the tree object to the tree data structure. And so we proposed having, as we have other tree
Yeah,
expression.
I think it's reasonable. It's amusing. It's bizarre.
I mean, given that there are several data structure types for trees, this also offers the opportunity to specify which one.
Indeed. I like it. Yeah. Data structure tree. I mean, I don't know why normal doesn't just convert to a tree object.
It could. We could do it too.
Fine.
Normal of the
You mean
data
normal
structure.
of the data structure?
Yes.
They already have their own normal form.
I see. Yes.
What do you mean their own normal form? It isn't a tree? What the heck is it?
What tree does currently, if you ask normal, is it gives rules.
Well, maybe it shouldn't. Maybe it should give a tree. Talk to the data structure people. I would suspect it should give a tree. But so we may not need a data structure tree function. Okay.
Data. I see.
Although there may be some options in the way it's converted, so it might be useful to have.
And by symmetry, given that we have these pairs of converters.
Okay. Let's have it.
And one final question. Do you agree that the structure that we return from the tree should be a copy, not the original one that it would be mutable and therefore it could break
From
the
data
tree?
structure tree. You're asking, what should data structure tree be? Yes, I think it should peel off an immutable structure.
A tree data structure, actually. So from the tree, we extract a data structure, which internally was mutable, and so we will produce a copy.
Gosh. Oh, absolutely. Absolutely. It will be completely bonkers for these things to for that to reach into the innards of the actual tree, which happens to be implemented with a mutable data structure.
Right.
Bonkers. Yeah.
Okay. Good.
Okay. All right. Let's move on here. Okay. If you want to hear about you probably don't. I mean, I realized that there's a whole, with our whole story of multi-way systems, which we need to, we are working towards having a multi-way system function. I don't know what meetings we have set up for that yet, but that's something I want to do. But okay, this is our conceptual moment here. Right now in our evaluator, we have the idea that there's a single chain of evaluation, right? It's bizarrely related to this weird post that I wrote about consciousness, which is all about threads of experience. And it's the same thing with our evaluator, that the evaluator just imagines you have an expression, things happen to it, and you get another expression, right? In a multi-way system of the kind that we think happens in, for example, quantum mechanics, et cetera, that isn't what happens. Instead, you get this whole big graph of possible outcomes, okay? So my little exercise was, imagine you were redesigning our language with the evaluator as sort of a quantum evaluator, where everything is done through a multi-way system and there's not a single thread of evaluation. What would things look like? Did that idea make any sense?
So what is offering the possibilities? Because sometimes there is just one thread you can follow.
Absolutely. But my point is this. Okay, so if I say resource function of multi-way system of something like A goes to AB, I don't know, A goes to AA. I don't remember. I've got some good examples of this. B goes to BB goes to A or something. I'm not sure that's going to do anything interesting. Whatever. Just make up some random thing here. Oh my gosh, what did that just do? I'm going crazy here. What did this just do? Oh, this is some bug in this version. Did you see that? Did you see that?
Yeah, I saw it appear later.
Right. Well, okay, let's go back to a version where it isn't buggy. What the heck? This is 12.3 I'm running here. So you should report this bug.
I got it, yeah. Took a few screenshots.
Okay. Oh, I'm sorry, this is taking too long to do, but wow, weird thing with this bug. Okay, so you understand what this is doing roughly, right? Instead of in ordinary evaluation, you just go down, ordinary evaluation is always a single path, right? So for example, replace versus replace list. Replace just replaces the first instance. It's a particular evaluation order. Replace list would do the same thing that this is doing. Okay, so the challenge is, this is like non-deterministic computation. This is like our usual thing is like a Turing machine. This is like all paths for a non-deterministic Turing machine. And the question is, what are the natural programming primitives in that situation? Okay, that's my little exercise here. Anyway, it's just a thing to think about. Coming attraction, let's say. Okay, Sandra is asking, can you also do a map where one has access to both the tree and the data, like map indexed or map thread? Boy, what is the analog of map indexed for a tree?
Well, on the first thing, if you have the tree, then you have the data.
I see what you're saying. I see what you're saying. So if you do the subtrees case, you could always extract tree data.
Yeah, it's strictly more powerful.
Fine. Fine, that's a good answer.
And I think map indexed is there's a sensible tree map indexed where the second argument would be the position that you're at.
Okay, which we can consider introducing. Map thread.
We have discussed that. For example, something we were interested in is comparing two trees. So a function that takes two trees and
heck yes. I mean, that's what we need for expression diffs, right? I mean, we already have some expression diff functions, I think.
Right. So
that's what we need. Yeah.
So I think it is possible if we have two trees of the same structure to the threading. So it will be like the normal map thread, which is a function that requires common structures.
Right.
To be able to compare.
But by the way, the tree diff function is really an important function. Right? How would we, that's a function where we want to annotate a tree. I mean, that is directly useful in comparing two expressions, right?
Yes, yes.
And I believe we have some such functions that have been built over the years.
Mm-hmm.
But it will be good to understand that better. That's a really good use case for things to do with the trees.
Yeah, we have thought about it as an application, but I'm not sure it will be ready in the first round of functions.
I understand. I want to add it to my list of student projects. Hold on 1 second here.
Yeah, I do remember in author tools, I think we had a tool to compare notebooks.
Yeah, right.
There's an expression line diff in the function repository.
Okay. All right, let's start taking a look at these. Multiple axes plots. We know perfectly well this is going into the system, and that's a Brett story, and he better be working on it. I mean, that's access object was a preliminary to that. Make sense?
Yep.
Good.
Dynamic face grids behind.
Basically, it makes it so that as you spin around a 3D graphic, the grids, the faces all look nice the whole time.
Sounds right to me. I mean, I don't know why we don't have that for face grids automatic right now. That's a Brett story.
Right. This implementation is probably heavyweight, but the idea is there.
Yeah, but so Brett is the one who should look at that. Okay, map cases. I think we'd started looking at this one last time.
Exactly. Yep.
I think it's a good idea. I mean, I've certainly wanted that. Oops. I've certainly wanted that functionality. Sandra is asking, is map thread updated for ragged lists? Do you know what's happened with that?
Map thread for ragged lists? Not yet. So we have discussed various generalizations of a map thread, but none of them is implemented yet. It's in the works.
Okay. We'll be interested to see. Tally has been promising his new meta theory of arrays. It'll be interesting to see what that looks like.
Mm-hmm.
Okay, map cases. All right.
Will this new meta theory of arrays decentralize the central dogma?
Of which? Of data set?
association and list more?
I don't know. I think it's more something. I mean, look, Tally developed the whole data set query mechanism, and I think he's realized that it isn't all it was cracked up to be, and it's kind of hard to understand. And so I think this is an effort to develop a new way to do those kinds of things. But we'll see. Okay, map cases.
Yes, Tamir.
What's that?
Nothing.
I mean, I like this functionality. What details does it have here?
It's mostly copied from other similar functions.
Evaluate cases. Whether to evaluate inside held expressions. Okay, that's a different issue. Okay.
So the discussion last week was that so this will be implemented more or less first you do positions and then you map at.
Yes.
So it's one of these functions which is more or less an obvious combinations of two existing functions.
Yes, but it's still conceptually, I think it is, if it has the right name, it's conceptually useful.
Mm-hmm. So then, for example, map. So would it return a list of the cases, or it would return the?
No, it would just return. It does exactly what map does, but look. The reason this is useful, okay, and it is really quite useful, is I can imagine something which has two levels of capability here, a pattern gate, so to speak. So I mean. Okay, so in this version, there's pattern and there's level spec. Okay, here's the thing. I want to map onto all list pairs that occur inside an F. So in other words, as you go down the tree, I mean, I've wanted this kind of thing many, many times. That is, you've got a definition of mapping, and essentially what it is it's a wrapper around F that says if F doesn't match this pattern, the function is sorry, if hash doesn't match this pattern, F is identity, otherwise it's F.
Right. We also have map if, which is similar, but instead of a pattern, it's a test. And they're conceptually similar to map at, except instead of giving an index, you're giving a pattern. Right.
And how does it relate to replace all? Replace pattern goes to F of pattern.
I think it. Look, okay. So
well, I mean, it works at multiple levels, right? I guess. Yeah.
Well, that it is related, but I would prefer to think about a headdress here, something like, I mean, okay. Look, this is the wrong name, but apply if matches. F comma pattern. Or something like this. Something.
That's the operator.
That's the operator, yes. That's the operator. And then you put that in, because then you can put it in map, you can put it in fold, you can put it in all kinds of things. Well, no, you can't put it in fold. You can put it in map. What will be a good name for this?
And if it doesn't match, it returns it. It becomes identity.
Exactly.
Right.
Well, yeah.
Match applied.
It's almost a filter.
Match applied. Yeah, so it's like reverse applied. How to apply matched applied.
Apply if.
No, because it's got to be an applied family.
Yes,
Well,
yes.
I mean, okay, applied if.
But if would want a condition.
Oh, no,
rather
no, I
than a
know. That's a
pattern.
different
Yeah.
case, right? That's the two cases. I mean, it's applied if. But that's not actually an interesting case, applied if, because that thing. No, it is an interesting case. That's the condition case. And then it's applied
match Q.
or applied matching. Applied matching. Applied if is a nice name. So that would be a test and an F, I think. Or maybe the other way around. Applied if test. Yeah, that's more like, because it's more like than the confirm setup. That's kind of nice, actually.
So both F and test would receive the argument.
That's correct. Test first.
Mhm.
Test runs. If test works, it applies F, otherwise it doesn't. So for example, applied if would be very commonly would be something like, hash greater than 0. Because that saves you from writing, if hash greater than 0, hash, if hash less than 0, hash, otherwise F of hash, which I write all the time.
I see.
Okay, so then the question is, what is the corresponding thing for matching?
Applied on.
Where do I put these, by the way?
You have a folder called WFR functions, or the ILD folder. I think you've saved in both places before.
Okay, so wait, what was the applied on?
Mm-hmm.
I don't like that. It's more like well, how do you give some sort of conditional? Applied match Q is very weird. Applied if is really kind of nice sounding.
Pattern applied.
That sounds wrong because it's like reverse applied, but not, so to speak.
Well, if it has to be similar to applied if, it could be applied if match. But it's already
Yeah.
3 words. Oh, you have it there, yeah.
Applied matched.
And what not match applied to follow reverse applied and operator applied?
Why would that make sense for operator applied? I mean, why is that like? It's actually not totally silly. Okay, so match applied would have the thing about pattern. So remind me, with operator applied, what we're doing is we're saying F. If F is operator applied, no, it's F of X is operator applied to Y.
Right.
Match applied isn't hopeless. Applied if and match applied. Let's investigate those more. I kind of like those. I think they're useful, like functional programming constructs.
I wish the order of the words wasn't different between the two.
I wish it wasn't different as well.
Test applied instead of applied if.
I like that.
Although I really like applied if. So it'd be great to see if there's a way to get the matching one that way round. Well, preliminarily test applied and match applied. See, we've got confirm. Let's see, we've got confirm by, which is a test.
Apply on match. On matching.
Well, I think it's applied on matching, and then that gets a little weird. Suggests some kind of temporal structure. All right, let's push forward. These are interesting. Match applied, test applied, with applied if being in second place there. Image color replace. Do we have anybody from image processing here?
No.
What's that?
No, I don't think so.
Okay, then we can't discuss this without them. This is basically a green screen function. It's up to them. We need them in one of these meetings. Okay.
Yep.
Pretty form. We already said send that to Brenton, right?
Yep.
Okay.
Yes.
Slice. How many different functions do we need here? I mean, we've already had extract. Why isn't this just an operator? Why isn't extract got an operator form like this?
I mean, it already has extract of something.
So why is this any different from that?
Well, extract and part are slightly different. I'm not supporting that we have an operator form for part, but the fact that we have one for extract is not enough, because position specs and part specs are different.
Right, but this is saving the fact that part with one argument, because part is var args, that part with one argument is the non-part, so to speak. This is an attempt to work around that issue.
Right, but I mean, these could support also multi-argument part specs.
So what's the point of that? I mean, yeah, I understand that it could have.
I mean that even if part of X was not X, this would still be more powerful. But again, I don't think we need.
Yeah, I don't think this is a good thing right now.
Right, we have nice ways of accessing part with double bracket, etc.
Yes. Okay, to regex.
Right. If this works well, it'd be great.
I mean, really what this is, we've got this function, regular expression, right?
Mm-hmm.
Okay, wait a minute. This is displaying this in some funky form, right?
As a regex.
Oh, as a string regex.
It's converting between Wolfram string patterns.
No, I understand
regex,
that. I understand that. But we have a representation for regexes, which is regular expression of blah.
Right. It's a wrapper.
Right. Yeah. So to me, this is like, the story would be this is to regular expression. And it would take in, whatever it is, dot, for example, and turn that into regular expression of a star or whatever it is.
Sure, it should have the wrapper on the output.
Yeah. Or what about the other way around, from a regular expression?
Do we have one of those, Danny? I don't remember.
I mean, it's not always
I
possible,
also
but it's
do.
usually possible. I think it is always possible in some form with slash semis and things. Well, I would say that I don't consider this super high priority, but I think it is nice to have. I mean, one thing we do need, and it's something that we should develop, and actually it's something we could develop initially as a data structure, is finite automata. Okay, we've had various packages for that. I think we need to, actually finish the job and have those. And the reason they're non-trivial, like trees, have a little bit of extra plumage beyond what's on graphs. For finite automata, the edges get labeled with things, and they're do you get what I'm saying?
Yep.
You know what? We should add that to Sushma's project list. I think it's something we should consider doing.
You add too many things to that list and it becomes infinite automata.
Yes. Sandra is commenting that in map cases, you could have a side effect. Actually, I don't think his example is correct, but I mean, in general, with applied if, well, yes, you could have a nasty sort of side effecty criterion there.
Yeah.
For sure. That's up to you. Okay. Cell information.
What was the decision on to regular expression? I'm wondering.
I would say yes, but low priority.
Okay. Is the name okay? Should it be to regex, string to regex?
No, because it's.
If we're going to return a regular expression object, then the name is fine.
I think the name is fine. And I think we also need from regular expression.
Now that in general can be done or no?
Yes, I think it can be done. I mean, it might require slash semicolon conditions.
Okay.
This is not high priority. I think it's a nice to have. And I wonder, in a case like this, whether we shouldn't annotate somehow the function repository, or at least so that somebody can know that this is something that will be nice to change in the function repository. Now, it's not a sensible idea. Never mind. Okay, cell information. So what is the difference between this and options of evaluation cell?
I think this has more stuff in it.
Okay, so there's a bunch of stuffing, so to speak. Options of evaluation cell. Okay, I am confuzzled here. So these are a non-overlapping collection of things, so I don't understand this.
Right, I'm surprised that the options aren't in the cell information one. But I mean, you wouldn't expect style to be in options, right? It's the second argument.
Right. But the real question that I have is why is information not working on evaluation cell?
Yeah.
That seems like the place to put this.
Yes.
I think this is a useful thing, but I'd like to understand what some of these things actually are. By the way, I also would like to comment that I think cell change times should become data objects. I think these are kind of bonkers. Am I making sense?
Yeah.
Anybody?
Yeah.
Yes.
I mean, that's
Can you take that to the front end group, maybe for version 13?
yeah, that's a front end question. Yeah. At least they should appear that way, even if they're stored different, right?
Okay. Okay. So I think the answer to this is yes, we're interested, but how does this relate to information and what are all these properties here? Okay. From character name. This seems like a useful function. Although, to what extent is it similar to entity? It seems useful to me.
Yeah, there are some cases that where this is uniquely useful in properties and relations. I don't know if there are things that are missing in. Yeah, it's not the same as just wrapping it in slash bracket. You know.
No, this is a good idea. This is a good idea. We should have this. Yeah, so this goes along with from character code, right?
Yeah. I mean, be on the same guide page.
This is a good idea. Okay. I vaguely heard of this thing. It seems useful to me. I don't see any reason not to have this.
One thing is that there is, I think, this ongoing linear algebra overhaul. So it probably should be done in.
As part of that whole. Yeah, it sounds right to me.
I don't mind implementing it. It's my code, but I don't want to go behind Devendra on that.
Yeah, okay, fine. Just coordinate with him. I mean, this is not a high priority. Just coordinate with him.
Okay.
Has definitions queue. I mean, this kind of is obviously useful. But really, it's some kind of down value queue.
Isn't this just doing the same thing that value queue does now, except it also checks for messages?
I'm not sure how it's implemented. I know it's looking for up values, down values, own values, messages, everything.
Okay, well, so the question is it equivalent to value queue? If yes, then we don't need it. If no, then we have to understand.
So the default.
And by the way, this better have a C also to value queue here. Should get changed.
The default method for value queue is symbol definitions present, which checks for down values, own values, etc. So that seems the same. But the thing is value queue does not check that messages are defined.
Well, maybe it should. Maybe it should. Why don't you look at that? See how, see whether there's a meaningful difference here.
Right.
Yeah, this is useful. This is useful. I have to say, I think we need more. I mean, the color maps we have, it's kind of random. You use, some jolly color map. I think we need to, and this is a discussion with Brett, for example, we need to come back and I've wanted things like this all the time. I don't think this is quite the right name, but this is a discussion we should have. Make sense? But it needs Brett.
Mm-hmm.
What the heck is this? Is this the equivalent of x equals hash?
Yes.
We don't need this.
It's popular. People like it, but I know that there are also people who hate it. And there's at least two of them in this meeting.
Go ahead.
We now have apply to.
Yes, but that's different. I see. You're arguing apply to suggests we might want set to.
No, the other way around, that apply to is more general than set to.
No, it isn't. This is equivalent to, this is an own value setter. Am I confused here?
No, I think I'm just thinking of apply to with identity or something like that.
Okay, so apply to has the thing you're applying to. What does it have? It has f and x, right? But which way around is it? X comma f, right?
Yes.
Okay, so what you're saying is this is x equals f of whatever this thing is here.
Yes, no, I'm withdrawing that. I think I was confused.
No, apply. I don't think apply to is an operator
yeah.
like that. It says x equals f of x.
Oh, okay,
It's
fine.
like an increment sort of thing.
Yeah.
Which
so
is then completely different from set2 in this setup.
I think so.
yeah. I was confused.
Okay, I think this is a no.
The name of this is wrong. If it came through today, it wouldn't get this name.
Well, unless that's some trade name effectively for that.
There should be a second word on it though, right? It should be regression or something.
Yeah.
Filter. But there should be a second word on it.
Yes, that should be.
Appears in neural networks, I think, or somewhere else.
Well, I agree. Having this as a filter seems useful.
Yeah, however.
Yeah, the function is useful. The name in the function repository is unfortunate.
Yeah. That said, it's probably a very nice thing to have.
Well,
Yeah.
so let's have it. Los filter.
That goes to Shadi's group, or
Yes.
Okay.
That's interesting. I mean, I don't know what this is the recursive association, because just association would do this.
Right, it goes deep.
Could association have a second argument that would do that? Or is that crazy?
I think association is var args.
It is. I would say not exciting right now. Bring it back again another time. I'm not convinced about that one. Totives sounds like some kind of animistic belief system.
Totatives.
Oh, totatives. Okay. Well, it's like totem poles or something. I don't know. Crowds with prime. Well, that's interesting. It seems useful. I mean, I've certainly wanted that a bunch of times. I just never heard the name, totatives. If that name is common, I say yes. Okay. I mean, it reminds me of totiant, right? But it's presumably it's the stuff of which a totiant is made.
Tomatoes, potatoes, and chives.
And totatives. Okay. We need to wrap up here in a moment. Oh boy, this is the analog of delete duplicates, isn't it?
Yeah. Of a sort, yes.
I'm not.
So probably there is a whole family here of possible functions.
Yes.
That do
well the set. Oh, I mean, unsorted intersection is another one, right?
Right. That's what I mean. That you could have an unsorted version of every set theoretical function.
I think we may have some of those coded in examples in the documentation. Not
well, but look, unsorted union, we don't have. We have delete duplicates, which is the one-legged union without reordering. I think we should consider unsorted union, complement unsorted. I think it's.
I know personally, delete duplicates of flatten is an idiom I use all over.
Yes. I think we should consider unsorted union complement intersection.
Yeah, having efficient versions of these functions would be very useful.
We should consider it. Yeah, various people are pointing out that totatives appear in various places in math world and so on. Okay. All right, we should probably wrap up here. Lots of exciting things to look at another time. It's not boy, there's a lot of stuff here. Well, good.
I think this is all just February 2019.
What do you mean? Really?
It is, but that was possibly the most prolific month.
That was the biggest. It was the biggest month yet.
We got good stuff going into the function repository. Very non-trivial and interesting stuff. The the one thing anyway. Okay, we should wrap up for now. Those who are following live streams, we have 2 more, and the next one I'm doing is a Q&A about history of science and technology. That's a recreational one for me. So for those interested, see you there. Otherwise, and I think we have another one in a few hours. That's a language completeness and consistency
Quick
meeting.
question. Somebody has taken notes about A, where we stopped, and B, what the dispositions are of the functions we went over today.
Yep, I got just about everything.
Thank you very much.
Okay, good.